All right, today we're going to find the easier ways of finding derivative rather than using the definition of derivative. And the power rule is the one we're going to use most often. The power rule says this: if you want to find the derivative, remember that notation, and a derivative of x to the n, where n is some number, all you do is you bring that n around front and you multiply by x and make that exponent one smaller. So if you had, for example, x to the fifth, what's the derivative? Use that notation. What's the derivative of that? Well, bring the exponent around front and make that exponent one smaller. And then there's the constant multiple rule for the derivative of a constant or a coefficient times a function. And coefficient just comes along for the ride. You will just take that coefficient and you will multiply it by whatever the derivative of that function is. So coefficients just come along for the ride. They don't go away. Now let's find some derivatives here, and let's do this kind of quick. If you got to press pause at any point, do it. Bring the exponent around front, make it smaller by 1. This one. Let's think of this as finding the derivative of x to the 3/5. If I'm going to find the derivative of that, I am going to bring the 3/5 around front, and now I got to make that exponent smaller by 1. And if you take 3/5 and subtract 1, or subtract 5/5, you got that. Well, let's see, constant multiple rule, we got a 5, okay, and we're going to multiply that by the derivative of x to the 6th, which is 6, x to the e. So I think we're going to get 30, x to the 5th. Coefficient just came along for the ride. Let's do some thinking here before we find this derivative. Let's think of this as being asked to find the derivative of -5 x to the -4. Okay, coefficient come along for the ride. Derivative of this guy, we got to bring that -4 around front. X to the, now we got to make that smaller by 1. And we're going to get a positive 20 x -5. And I'm going to be fine with that if you write it like that. If you also write it 20 over x to the 5th, where that x is now a positive 5 because you don't like negative exponents and been drilled into your head not to use them, well, that's fine. But I'll accept either one. Derivative of 13 squared. Well, again, we're going to do some thinking, and we're not going to think a whole lot on stuff like this anymore. Let's think of this as being asked to find the derivative of, let's see, 13 squared is 169, x to the 0, because x to the 0 is 1, anything to the 0 is 1. And so I will have my coefficient come along for the ride. And then I'll multiply by 0, x to the -1. Well, if you're going to multiply by 0, you're all done. This derivative is equal to 0. The derivative of any constant, the derivative of 169, the derivative of -6, the derivative of pi. There's no variable given to you. It's a constant, and the derivative of any constant is 0. Other properties, the sum rule. Okay, these are not even things that you need to write down, but just make sure you realize they're true. If you've got the derivative of some function plus another function, just take the derivative of the first one. and add to it the derivative of the second one, if you find that to be more convenient for you. And if it's subtraction, well, that just means you could subtract it. Okay? Find the derivatives individually. It's kind of like finding the limits of a sum or the limit of a difference. Same thing goes for finding derivatives. Now, for those of you who took AB, I think I told you about the dog last year. So I'm not going to worry about the dog this year. Just realize that if you're asked to find the derivative of a function that can be simplified, simplified means make things simpler. Before you find the derivative, make life simpler. Simplify the function. Let's call f of x, see, this divided by this is x squared, plus this divided by this, 8 x to the, well, this is x to the half, this is x to the 1, you subtract the exponents. So what's f primed of x? Well, the derivative of this, just find the derivative separately from each other, these two terms. Make sure you add the results. 2x plus, okay, bring the negative a half around front, negative 4, x to the, now let's make this smaller by 1, negative 3 halves. To leave it like that, absolutely fine. You know, now, that might be what you get. This is, let's say, a multiple choice question on the AP exam. And the option for the answer is this. Would you realize that those two things are the same? I'm okay with you writing it this way, but if it's a multiple choice question and you've got to identify the option, you got to realize that those things are the same. At least I sure hope they are. Find the equation of the tangent and the normal line. We don't know what normal is. Some of you might remember what normal is, but let's worry about the equation of the tangent line.
Please call 6487.
Oh, let's see. Let's use point slope form. That's pretty convenient. Y minus 16 equals, we got to find that slope. X minus 8. Okay, well, if y is equal to x to the 4/3, that means y, the y prime, the derivative, is 4/3 x to the 1/3. And the x value that we are interested in is this. And what is 8 to the 1/3 power? What is the cube root of 8? Well, the cube root of 8, and so my slope is 8/3. And there's the equation of my tangent line. Point slope form, very convenient, finding the derivative and therefore the slope. Not too bad. Now, this normal line, keep in mind what a normal line is for those of you who remember and for those of you who don't. The normal line is perpendicular, that's perpendicular symbol, to the tangent. Now, it's still going to go through the point 816. It's still y minus 16. Slope. And it's still x minus 8. It's the same point. But now what do you know about the slopes of perpendiculars? If running through your head right now is opposite reciprocals, you are absolutely correct. And the opposite reciprocal of 8/3 is negative 3/8. And now you've got the equation of the normal line. So, not a real familiar term. If you can remember that it is perpendicular to the tangent, shouldn't be too intimidating. Now, we're going to find the derivative of x cubed times x squared. Well, now, if I found the derivative, and let's see, maybe I'll simplify it. I think that's a good way to do this. F of x could be just written as x to the fifth. So f prime of x is equal to 5x to the fourth. And that is the correct answer. If you can simplify, do it. Now, there's going to be times, and it's going to be most times, you can't simplify. If you can't simplify, you may have to use the product rule. If this is one function times another. And the product rule says this, that the derivative of f of x times g of x. Well, first of all, let's get something out of the way. It's not the derivative of f times the derivative of g. If it was, I would take the derivative of this, and I'll do this in green, and it's trash, so don't write it down. I'll take the derivative of this times the derivative of this, and I think the answer should have been 6x to the third. Well, okay, we saw it's 5x to the fourth. This is trash. You don't just take the derivative of each one individually. No, the way we're going to find the derivative of one function times another is we're going to take the first function times the derivative of the second function, and then add to that the second function times the derivative of the first function. Now, when it can be simplified, you wouldn't do that. What we did up here in red is absolutely fine. But let's, just for giggles, let's find the derivative using the product rule. Let's take this first function times the derivative of the second function and add to it the second function times the derivative of the first and if we do that, I think we get 2x to the fourth plus 3x to the fourth is 5x to the fourth, and sure enough, it works. That is exactly what the derivative is supposed to be. Much easier to simplify, but again, in many cases, you are not going to be able to simplify, and you will have to use the product rule to find the derivative of some function times another. All right. We aren't doing that one. Final slide. The same thing is true if we have a quotient. If we want to find the derivative of f of x divided by g of x, you don't just take the derivatives of each of these individual terms, and yeah, this is supposed to be a minus, sorry about that. You don't just take the derivative of each individual term and then divide them out. No. Nope, there's a special rule. You don't just take the derivative of the top and the derivative of the bottom and divide them. Just like we saw that didn't work for a product, it's not going to work for a quotient. Here's how you find the derivative. You take the bottom times the derivative of the top minus the top times the derivative of the bottom and divide by the bottom squared. Now, you might ask, why do you do that? Because that's what James tells us to do. I just blindly follow James. Much smarter man than I am. That's quotient rule. Well, now, that might be tough to remember. So, for those of you who have never had this before, what we're going to say is that this bottom times the derivative of the top, we're going to call this low d high. The derivative of the top, we're going to call that d high, the derivative of what was up high. Low d high minus what was on top, which is high, times the derivative of the bottom, d low. And then we have the bottom squared, low low. So, quotient rule is low d high minus high d low over low low. And if you say that several times, eventually it'll just stick. It's something that you really don't forget. Low d high minus high d low over low low. So let's take a look at an example of a quotient rule here. Now this one does not simplify. And so if I want to find f prime of x, I'm going to take what's down low, which is x plus 6, multiply by d high, the derivative of the top, 3x squared plus 1, minus high, yikes, x cubed plus x minus 2 d low. Well, what's the derivative of x? What's the derivative of x to the first? That would be 1 x to the 0, which is just 1. Don't even have to write it. Over low low. Then the question always comes up, do I have to do anything with that? Do I have to simplify this, or can I just leave it like that? You got to simplify the top, leave the bottom alone. So let's see, if I foiled this thing, I think I would get 3x cubed plus 18x squared plus x plus 6 minus this x cubed plus x minus 2 over x plus 6 being squared. Now I'm hoping I make any mistakes, and if I did, well, you caught me. Fix it. If I combine like terms, I think I'm taking 3x cubed minus x cubed is 2x cubed. I think I got an 18x squared. I think I got some common terms here. X minus x. 6 minus negative 2. Over x plus 6 being squared. So hopefully I haven't made any mistakes. If again I have, hopefully you fixed them. That is what the derivative would be using the quotient rule. So those are some of the core methods that we're going to use to be finding derivatives, to be finding the slope of any function. To find the slope of this function at any x value, all we'd have to do is put that value of x in here, and we would know the slope at that particular number. All right, so practice finding some derivatives before we try to make this really complicated.